Okay, AP Calculus, we're supposed to be talking about particle motion, but I want to be clear that what we're really talking about here is how to use your CAS calculator to solve a function on a specific interval. So we have this, Seth, we have for t is greater than or equal to 0 and less than 6, less than or equal to 6, a particle is moving along the x-axis. So this is just a particle motion question. The velocity of the particle is given by v of t is 2 sine of e to the t force power plus 1. And what I want you to notice is the problem is this. We're asked at what time or times on the interval is the velocity equal to 0? Well, what sucks about this, Bill, is that this function is sinusoidal, right? So it's going to have this shape like something like a sine curve. It could be a cosine curve. Is also sinusoidal. Sinusoidal just means it kind of rolls up and down across the across its domain. So when I went to solve this thing the first time, it fell apart a little bit, and there are two ways that we could get around it. But I just want to show you what this curve looks like. So this curve is really nice and well behaved here, isn't it? Comes down here, and as you can see, it starts to get through its periods much faster, doesn't it? So when I went to solve this, when I used the solve function, it went really badly for me. It went really badly because it gave us the solution using the solve function in terms of a kind of an equation, right? A kind of a fill in the blanks. So it didn't give us a specific numeric value. And that's what they're counting on the AP exam, that you won't know how to do this, because most calculators won't do this. So here are two ways around this. One way around this I found is I could just redefine this. I could do this like this. I could go back and redefine this. Let's see if I can do it here. I could do this, control this, and put in such that, and then I could put in 0 is less than or equal to. This is in terms of x, although we had our function in terms of t. Sorry, I hope you don't mind, but right? Everybody got a note what I did there? So I create my interval there, and let's see if it worked. So then look, it cuts the graph off, doesn't it? Right? It makes it really obvious where you're going through. And then from there, Ken, if you wanted to, you could go to, I went to menu, and I went to analyze graph, and then what I went to was 0. And then they asked me for a lower bound. Remember, this at the bottom of the screen right here, Ken, it says lower bound. It's asking for an x value that's lower than the point you're looking, that's to the left of the point you're looking at. So there, I'm just going to put it here. And then you stretch it out, and you see I captured a 0 in there. Hit enter. And it says 5.2, which is a pretty good answer. It's not the best answer, but it's a pretty good answer. So you can look down at how the graph reconfigured this thing, and that's what it looks like. The other way I did it was this, and it really works. This works really, really well. Is I went to calculator. I typed in the function. I typed in the function like this. I said the function was 2. Was it? You know, I'm going to go back and do this correctly. Sine of e to the, and I'm going to use x force instead of t force if you don't mind. Is that all right? T force power plus 1. Then check this out, Seth. I'm going to use this little piece of this function. I'm going to say control here. And remember, this is the such that key. So we want this, we're going to define this on an interval. So by doing this, we're saying, I'm going to define this on an interval, and then I'm going to just type in what we had in before, which was that 0 is less than or equal to our x value, and our x value is less than or equal to 6. Are we good? And then from here, I'm going to hit Control Store. And on the AP exam, on that calculator section, there's going to be lots of times where you're going to be using that function over and over, so you might as well, right? So hit Enter. Sorry, I'm going to save this. If you don't mind, I'm going to save this as f of x. So f of x, enter. And it says it's done. All I'm going to do here, Jason, is I'm going to test this to make sure I'm right. So I'm going to just go back. I'm going to type in f of x really quick just to see what I get. And it worked out perfect, didn't it? Because now look what will happen. If we hadn't defined this using this interval out here, Kevin, if we hadn't used this interval out here, then we would have gotten this really horrible answer back. It would have given it in the form of an equation with n as a value. So this is going to work different. And now I'm going to use that solve function S-O-L-V-E, solve f of x is equal to 0. Remember, this comma here is just in terms of x. But remember, this f of x function right here is defined on an interval. And that's what is going to make this work right. If we didn't do it this way, we'd get that screwy answer. But look what happens when we do it this way. So if somebody freaks out and say, that crap, that's not any better, is it? Now what? Yeah, ask for the approximation, control, enter. And this is a really good clean answer right here, isn't it? So this is, go back to here, we had 5.19552. So go back to this. Here was our question. And we can write in that answer right here, right? We can write in the answer right here. And it was 5 point what? 19552, is that right? Which is better than what they did on the graph, which was rounded to 5.2, isn't it? So remember when you're watching this video that the video is about particle motion, Seth, but it's not really about particle motion, is it? It's really about how to use this calculator to define a function on an interval so we can use the solve function more effectively. You're going to have tons of chances to use this on the AP exam, I promise you that. So.